Hello and welcome to session 8 of the Biosafety and Biosecurity mentorship program for Northwestern Province. So in this session, we will mostly look at the biorisk assessment. So this is part 2 of the biorisk assessment sessions. So in part 1, what we mostly looked at are the basic principles of biorisk assessment. So we introduced risk, and we also looked at risk being a function of both likelihood and consequence. Then we also looked at some real-life examples of doing a risk assessment. So this is where we looked at what is the risk whilst you are crossing the road, and we also compared that risk to the laboratory setup. So that video has been uploaded. So it's uploaded in 2 parts. So make sure you watch the parts the way they are supposed to flow, so that at least you follow through the sessions. So there's part 1, which has which is titled Biorisk Assessment Part 1A, and then the second part of the Part 1 is titled Biorisk Assessment Part 1B. So make sure you start with the Part 1A, then you also look at the Part 1B. So let's get into today's session. So for today's session, we'll mostly look at biosafety risk assessment. So like we introduced biorisk in the previous session, we simply introduced it as being a combination of both safety and security risks. So but for this session, we'll mostly just look at the biosafety risk assessment. So we're going to look at a little bit more in details on what actually contributes to the risk. So what are we talking about? We're saying risk is a likelihood of, or risk is a combination of likelihood and consequence. So we're going to look at what exactly is affecting the likelihood, or what will affect the likelihood if you're doing a biorisk assessment just for biosafety. Then also what affects the consequence whilst you're doing a biosafety risk assessment. So by the end of this session, or by the end of this video, you should be able to describe the process of conducting a biosafety risk assessment. And then the second objective is that you need to explain the components of the biorisk management strategy. So these are our major learning objectives. Of course, there will be some other aspects that we'll talk about during the session, but then these are our major learning objectives. So let's just quickly recap. So we'll just redefine what risk is, and then after that we'll jump into certain aspects of the biorisk management strategy. So like we earlier defined it in the previous session, risk is the likelihood of an undesirable event happening. So this undesirable event needs to involve a specific hazard or threat and has consequences. So whenever you are describing risk, there should always be likelihood of something you don't want happening, and you also look at the consequences when and if that particular undesirable event happens. So in other words, we can say risk is simply a function of likelihood, or risk is a function of both the likelihood of something happening and consequences of that occurrence. So we really defined this in the previous session. So for more details on this definition, you can kindly just rewatch session 7, and you'll be able to understand further explanation on this definition. So in picture there, we have what we call a risk matrix. So the risk matrix that is in picture there was adopted from the WHO risk assessment template. So during this session, we will also look at how do you interpret this particular metrics and what do each of the likelihood and severity ratings actually tell you about your risk. So now let's look at some definitions of what biorisk assessment is. So we already defined it as well in session 7. So a biorisk assessment is an analytical procedure designed to characterize and evaluate safety and security risks in a laboratory. So it's an analytical procedure. So like we said in session 7, so it's an analytical procedure. It means that there should be something that you're analyzing. You can't just start or you can't just end up with the risk without actually analyzing some form of information and trying to determine certain factors that are analytical in nature about the risk. So it is always an analytical procedure. Of course, every activity and procedure conducted in a laboratory that involves infectious agents should be considered, as well as every asset, every adversary, and vulnerability within an institution, including its component laboratories and units. So, of course, there are two types of risk assessments, or biorisk assessments, or the components of the biorisk assessment is what we call, one is called the biosafety risk assessment, where you are just simply protecting people from harmful biological agents. So if you conduct a comprehensive biosafety risk assessment, it means that you would have at least protected people from the harmful biological agents that they are actually handling in the various institutions or laboratories. And for biosecurity, this is protecting biological agents from misuse. So you're protecting the biological agents that you are working with in the laboratory from misuse by the people who are actually handling these biological agents, or the people that may misuse these biological agents may not be part of the facility itself or the lab. They may be coming from outside of the facility. So these are what we call the outsiders. So in the biosecurity risk assessment section, we'll dive into deeper details on the type of adversaries you can have in the laboratory. So let's look at the biorisk management strategy. So the biorisk management strategy that we will talk about was adopted from the CWA 15793 2011. So it simply describes biorisk management as a three-legged stool, where biorisk management sits on top, and the three legs, one of the three legs is assessment. So under assessment, this is where you need to do your risk assessment. Then the second leg is mitigation. So whenever you do a risk assessment and you find that you have risks that are not acceptable or risks that may need some form of control to either reduce or eliminate those risks, you need to put up mitigations that will reduce or eliminate this risk. Then if you put up your mitigation strategies or you implement your mitigation strategies, you need to check whether or not these mitigations are actually working the way you hoped they would work. So you check for the performance of these mitigations. So if you find that these mitigations are not actually making a difference, they are not reducing or eliminating the risk, what you need to do is you need to go back and do your assessment again, put up new mitigations, and then after you put up new mitigations, you check again if these new mitigations are working this time around. So it's more of a cyclic type of biorisk strategy or management strategy. So just like a three-legged stool, if you remove one of these, that is the assessment, mitigation, or performance legs, it means that the biorisk management strategy itself will not be able to stand, it will fall. So you need all the three legs for the biorisk management strategy or your biorisk implementation in your lab to actually work. Either of, if you remove one or two of these legs, then everything breaks down. So let's look at the components of the biorisk management strategy. So what are some of the things that you need to do for you in order for you to actually have a biorisk management in your laboratory. So the first thing you need to do is you need to describe work activities. So what does this mean? So you need to know what activities are being done in your laboratory. You need to know each and every activity you're doing in the lab. So are you doing serological tests? Are you doing culture? Are you doing um, uh, procedures that are using equipments? Then for each of these work activities that you're describing, of course, they will involve a certain particular biological agents that you are either analyzing or you're testing for or you're researching if you're coming from a research lab. So now, after you describe the work activities, you know what you're doing in the lab, you know everything that you're doing in the lab. The next thing you need to do now is you need to identify the hazards and you need to identify any threats that may be involved in these work activities. So like I earlier touched on, so each of these activities that you're doing involve or will involve a biological agent being tested or being handled. So mostly the hazards that you have whilst you're doing these activities in the lab will be biological in nature. So you need to identify these biological hazards or biological agents that will be affected in the activity that you're doing. Then you also look at what are the risks now that these biological agents will pose or will have whilst you are doing the work activities in the lab. So under determining the risk, this is where now you're doing your hazard characterization or you're doing your agent characterization. Then after that, you determine what is known as your likelihood. So for you to know the risk, like we already described in the previous session, you need to know the likelihood of exposure and the consequence if you get exposed to this biological agent. So under determining of risk, you just simply look at the characteristics or certain factors that will contribute to the likelihood of exposure to these biological agents and the consequence if and when you get exposed. So the first three steps where you're describing work activities, you're identifying hazards and any threats, and also you're determining the risk mostly by determining the likelihood and consequence. That is what we are calling risk characterization. Okay, so the point or the steps from work activity description, hazard and identification, and then also you're looking at the likelihood and consequence without actually determining the actual risk is what we're calling risk characterization. So now what happens if you determine your risk? So you've done your likelihood and consequence determination, and then now you've also said, okay, the risk here is either low, moderate, or high. So what happens? So the next thing you need to do is you need to decide. So as a person doing the risk assessment, as a team doing the risk assessment, or as a facility, you need to decide whether or not the risk that you've found is acceptable or not. So there are two steps or there are two routes you follow after you do your risk determination or your risk acceptance. So one of the routes you follow is is if you say your risks are acceptable. So you do your risk determination and then you find that, okay, your risks are acceptable. But of course, before you decide whether or not the risks are acceptable, you need to put in mind the control measures that you've already put in place as a facility. So you put in mind, okay, what have we done to actually either reduce or eliminate this risk? So after you've put in mind or you've considered all the control measures that you've already put in place to either reduce or eliminate this risk, you then ask yourself, is this risk acceptable? If the risk is acceptable, so if yes, if the risk is acceptable, you need to proceed with work and you monitor your controls. So you monitor the controls that you have already put in place as a laboratory. So you don't just proceed with work and forget about the risk and say, okay, we are working in a safe laboratory, so therefore we don't really need any more control measures. You need to also check what you are already doing. Is what you are already doing working? Because sometimes you find that the laboratory will forget to actually check or monitor the control measures that they already had put in place before determining the risk to be acceptable. And if you are not checking, those control measures may work against you, because maybe at some particular point they may not actually work the way they were working before or after you did your risk acceptance. So at this point, you need to also do your risk performance or your mitigation performance checks. Okay, so now what's the other route? So what if you do your risk determination and then you find that your risks are unacceptable? Of course, you also need to consider what you're already doing. So what if you find that your risks are unacceptable? So if no, so now if the risks are unacceptable, there are two possible things that you will do as a laboratory, or there are two possible steps or processes or procedures that you need to do. So as a laboratory, if you have the resources, if you have the manpower, and if you have the know-how, and you are sure that you can reduce or eliminate this risk, it means that at this particular point, when you say this risk is unacceptable, you need to now start preparing your risk control measures, or you need to put up your risk control strategy. So here, what the steps you are doing while you're accepting whether a risk is acceptable or not, and if it's acceptable, you proceed with work, and if not, so that is what we are calling risk evaluation. So let's look at the next step. So if you have all the resources, like I earlier mentioned, and you are sure that you can reduce this risk, you need to now prepare risk control action plan. So you need to prepare, or you need to decide as a laboratory to say, okay, we can reduce this risk, and these are the controls that we think can work to reduce this risk. So you prepare a risk action plan. But then most of the time, your risk action plan will have like a lot of possible risk control measures that can either reduce or eliminate your risk. So after you prepare your risk control action plan, you need to decide now or select which of the control measures will actually work, or which control measures you feel will actually work by reducing or eliminating your risk. Then after you select them, the next thing you need to do is you need to implement the control measures. So if you are working in a lab and you find that you are handling, let's say, Ebola, and then you decide or you find that the risk of you actually processing samples for Ebola is very high, and therefore it's unacceptable for you to actually do or perform the tests for Ebola. You need to now put up measures that will either reduce or eliminate the risk of you handling Ebola in that lab. So what are some of the examples that you may think about? So in this case, you may say, okay, we need new infrastructure, which means we need to build maybe a level 3 or level 4 type of facility, or you need to put up certain containment barriers that you may not have. Maybe at the time you're doing risk assessment, you only had a class 2A2 type of biological safety cabinet, But then if you need to handle Ebola, you need something a bit more or something which offers a bit more containment. In this case, maybe you may need a class 3 biosafety cabinet. So you actually redesigning your lab and you getting that containment device are proposed control measures. But then you need to implement now, you need to buy this class 3 biosafety cabinet, you need to renovate your lab. So now this is what we are calling your implementation phase. So you implement by actually making the plan work. So you implement. So after you implement, you need to now look at other factors, but the steps where you are preparing your risk control action plan and also you are implementing control measures, that's the second arm or the second leg of the risk management strategy, which is your mitigation. So if you remember, we defined risk assessment as an analytical procedure where you are characterizing and evaluating your risks in the laboratory. Yeah? So the parts where there's risk characterization and risk evaluation, that's the assessment part of your leg. Now the preparation of control action plan and implementing the control measures, that is your mitigation. So that's your second leg of your biorisk management stool or strategy. So now what happens after you've implemented your risk control plan? Do you just wait and leave everything to chance and you don't even check whether or not that biosafety cabinet, which cost you a lot of money, or that renovation that you did, which also cost you a lot of money, do you just sit and wait and hope for the best that they are actually working? So there's another step now you need to do where you need to review the adequacy of the risk control plan or your risk control action plan. So you check, is this biosafety cabinet, the class 3 biosafety cabinet that we bought to either reduce or eliminate this risk, is it actually doing the work it's supposed to do? You check. So we've redesigned the laboratory. So is this redesigning of the laboratory, is it actually reducing or eliminating the risk of us getting exposed to the Ebola that we're actually handling in the lab? So you check, are they actually working? So whilst you're checking, you're also looking at the practices. So are people actually using the biosafety cabinet the way they are supposed to use it? Are people using the facilities that have been redesigned the way they are supposed to use them? So under review, you don't just check what you did, you also check, are people actually using the things correctly? So you check all those things, because sometimes you find that a risk control measure will fail because the people are not using the risk control that you actually implemented or actually proposed the way they are supposed to use them. So the risk control will fail because of maybe the people not understanding how they're supposed to actually use this new technology or this new facility. So you may uh, uh, also want to check that part, the practices, because what you don't want is you don't maybe you don't check if people are actually using the things the way they're supposed to use them. So you may think the class 3 is not really the heightened control measure that you may need, and then you may want something even bigger than that. But then the problem was not really about the equipment itself. Maybe the problem was just the implementation strategy that you used. People did not understand how to actually utilize that control measure, and therefore it did not work. So you need to check all these things. So this part where you are reviewing adequacy of the plan is the third leg of the stool, which is your performance. Okay, so what happens now next? You've checked your performance, but then after you check your performance, what's next? Like, do you just check your performance and then you say, okay, we checked the performance and that's it? So after checking your performance, you need to go back and ask yourself the question of, is this risk now acceptable? So remember, this risk was unacceptable in the beginning. That's why we went through all these processes of trying to reduce or eliminate it. So now you ask again, is this risk now of us handling Ebola, is it now acceptable? Has the risk reduced, or have we completely eliminated the risk? So you ask that question again. So if the risk is acceptable, you follow the if yes route, and therefore you proceed with work. But remember, you had implemented something to reduce or eliminate this risk. So you need to constantly monitor that, or those control measures that you implemented that either reduced or eliminated this risk. Because what you don't want is the risk increasing because you didn't really monitor your control measures. So at this particular point, you continuously monitor. So, but then what if you put up your biosafety cabinet class 3, you do these facility features, but then the risk is still unacceptable. The risk has reduced, but the level of that risk is still unacceptable. So there's a positive, it has reduced. You've at least reduced the risk, but the risk is still unacceptable. So what that is telling you is that your risk control plan or your risk measures that you implemented were not really adequate to either reduce or eliminate this risk, or they were not really adequate to reduce the risk to a certain level where it's acceptable. At this point, you need new control measures or additional control measures. Not really new, you need additional control measures. So if you have the resources, and if you as a laboratory, you have everything you need to actually put up additional control measures, at this point, you need to again prepare a risk control action plan and implement those new or additional control measures. Then after you implement those new control measures, you come back again after maybe a few months, you come again and check, are these control measures that we've now implemented working or not? So you check performance again. As you're checking performance, check practices as well again, so that you rule out the human factor for these control measures. So now, if you review these new or additional control measures, what next? Again, you need to come back and decide, okay, now we've added on things from the biosafety class 3, we've added on from the facility features that we did, we've done ABCD, we've had people vaccinated, so there are these new things that you've done. So now you are saying, okay, is this risk now acceptable? So you come back again and decide, okay, is this risk acceptable? So if the risk is acceptable now at this point, it means you go to the if yes. So if yes, then you proceed with work and monitor the control measures. So now you're monitoring the control measures that you put up, the class 3, maybe biosafety cabinet you bought, you're checking the facilities, if they're working okay, and the additional ones that you put up. So you're checking the vaccination, is it working, or anything that you would have implemented. Maybe if you realize that there was a human factor, maybe at this point you're checking, is the training working? Are the procedures that you actually put up so that people understand what they're doing and they standardize what they're doing, is it working? So you continuously monitor that as well. So now, what if in this second cycle of implementation you find that the risk is still unacceptable? So you are doing your risk acceptance, then you find that your risk is still unacceptable at this point. So if you as a laboratory, you still have the power, you still have the resources, you still have everything you need to actually implement, or you still feel there's still more you can do and you have the resources, you go back and prepare a risk control action plan. Okay, after that after you implement, check or review adequacy of the plan, then do your risk acceptance again until your risk is now acceptable and you proceed with work and monitor the controls. But if at this particular point you find that you do not have the resources, you've done what you can as a lab to either reduce or to try and reduce this risk or eliminate it. But then at this point, your budget is exhausted. You don't have any more money. You don't have anything more you can do at this particular point. Then there's the next step that you now need to do, or the next decision that you need to now follow, which is the if no, which is going down there. So if at that point there is nothing you can do, there's no control measure that you can put up, you revise or close the project, because at this particular point you've determined as a facility that people will still be exposed, or the risk of exposure to this to the people in the lab to this Ebola is still high. So, and there's nothing we can do about it. Therefore, you revise or close the project. So now, how do you revise or close the project? So if you're doing testing, the simplest way to revise or close the project is you can decide as a laboratory to find another lab which has the resources to actually handle that particular agent. So you can refer that agent, or you can refer that agent to them. So whenever you have samples of Ebola, you send them to that particular lab to actually do the testing, because they've actually or they have the proper mitigations that are reducing or eliminating the risk of testing for Ebola. So of course you need to check their risk assessment. Check that they actually did a good job on risk assessment, that they've actually reduced or eliminated the risk of testing for Ebola. Because what you don't want is referring samples to another laboratory, and then you find that now you overwhelm them and then they start getting exposed because they didn't really do a proper risk assessment. So make sure you check their risk assessment as well. So that's one of the ways you can actually revise. Then another way you can revise is if you are doing culture for a certain test. Let me give another example. If you're doing culture for cholera, at this particular point, you may try to review the procedure itself entirely. So at this point, you may just decide to say, okay, we cannot really reduce the risk of us culturing, let's say, cholera in our lab. The risk is too high. Therefore, we won't culture the samples. We'll start doing some form of serological test. That way, you've reduced the chances of you getting exposed to Ebola through culture, because in the sample, most of the time, the concentrations will be less as compared to a culture. Therefore, at this particular point, your entire procedure will change, and therefore, almost all your mitigations will change. You may not need a biosafety class 3 type of facility. You may not need all these extra features. All you're doing is receiving a sample. You get part of the sample, you put on a testing strip, and then that's it, because that's what your facility is able to handle. Or if you're doing a research and then at this particular point you find that the risk is still unacceptable, you just need to close that project. If you cannot find another laboratory or another researcher that can help out, all you need to do at this point is just close the project, and that's it, because what you don't want is to continuously work in that laboratory and to continuously expose people to these biological agents. So continuously expose yourself as well to these biological agents, because the main thing of risk assessment is we want to reduce the risk of exposure to these biological agents. So that's the biorisk management strategy. Okay,